Assalamualaikum warahmatullahi wabarakatuh and very good morning. Today I will teach you about Ohm's law. In this chapter, I will cover objective, note, video, interesting video, simulation, quiz, and experiment. First of all, I will show the objective. By the end of this session, students will be able to define current, define voltage, define resistance, and define the concept of Ohm's law. Students be able to solve problems systematically through discussion and application of some important mathematical technique and procedure. Mathematically, relate the three basic quantity, current, voltage, and resistance to the concept of function. Okay, we're going to note. Okay, Ohm's law states that the current I flowing through a conductor is directly proportional to the potential difference across the end of the conductor. If temperature and other physical conditions remain constant, okay? If physical conditions remain constant and temperature. Mathematically, Ohm's law is written V equal to IR, where V equals to potential difference, V, unit is V, and current is unit M, current is I, and R is equal to resistance, unit is ohm, like this. Okay, we go through the note. Ohm's law tells us that if a conductor is at the constant temperature, the voltage across the end of the conductor is proportional to the current. This means that if we plot voltage on the y-axis of the graph and current on the x-axis of the graph, we will get a straight line. The gradient of the straight line graph is then the resistance of the conductor. So this is a general formula V, I, and R. We make in pyramid shape. Okay, the resistance R is a term that describes the position experienced by the electron as the flow in a conductor. It is also defined as the ratio of the potential difference across the conductor to the current I flowing through a conductor. Current is I. Okay, next we are going to videos. Okay, this is not video and this is calculation video. I will show you some. Okay, it's quite delay.
We talked about potential difference in current, but how are they related? The Ohm's law, which is probably one of the most fundamental laws of electricity, explains this relationship. George Simon Ohm, after whom this law is named, was a German physicist of the early 19th century who spent many years researching on the factors that affect current flow in a battery. We found that the current in a steady-state conductor is proportional to the voltage between the ends of the conductor. So if V is the potential difference of this conductor from point A to point B, and a current I flows through it, I is proportional to V. What Ohm also discovered was that the current is inversely proportional to the resistance offered by a conductor. What is resistance? Imagine a river flowing downstream from a mountain. The river will encounter several rocks and boulders which will block its flow. In other words, the rocks act as a resistance to the flow of the river. Similarly, conductors also offer resistance to the flow of current. So if R is the resistance of the conductor, I is inversely proportional to R. Combining these two terms, we get I is equal to VR or V is equal to IR. The reason why we represent Ohm's law as V is equal to IR is because it's a lot easier to print in textbooks and reading material. Let's dwell on this resistance a bit more. There are two kinds of resistances offered by a conductor. The first type is to do with the material of the conductor. As the free electrons travel through the conductor, they also experience a force from the positively charged nucleus of the conductor atoms. This force of attraction resists the flow of current. The attraction force is more in certain conductor materials and less in other, depending on the type of atoms they're composed of. The size and shape of the conductors also affects the resistance they offer to current flow. Instead of having a conductor of length L, let's take a conductor with double the length 2L. This now means...
Okay, next we are going to calculation video. Calculation will teach you how to
using Ohm's
calculate.
law to find electrical quantities in simple circuits.
Okay, using general
Here is
formula.
a simple circuit consisting of a battery or voltage source connected by conductors or wires to a resistor or resistive load. The voltage of the power source is 100 volts and the resistor has a value of 5 ohms. What is the current flowing through this circuit? Well, to remember Ohm's law, we want to find here current, so we need the formula for current, or intensity of current, I. If we cover up I in the Ohm's law memory aid, V over IR, we cover up I, that gives us V over R, or we'd say I equals V divided by R. Current equals voltage divided by resistance. So in this case, we have 100 volts for the voltage and 5 ohms for resistance. That would be 100 volts divided by 5 ohms, which gives us 20 amperes. So 100 volts would push 20 amperes of current through a 5 ohm resistive load. Look at another example. Again, the same circuit, but this time we know what the current is, 3 amperes, and the resistance in the circuit is 10 ohms. We now want to know what is the voltage, V or E, across this circuit. Remember, sometimes people use E for voltage, and other times the symbol V is used. So don't let that confuse. Here we're using V primarily. So the formula that we need from Ohm's law would be, according to our Ohm's law memory aid, if we cover up V, that gives us IR, or voltage equals current times resistance. V equals I times R. And that is 3 amperes times 10 ohms, 30 volts. So 30 volts is pushing the 3 amperes of current through the 10 ohm resistor. We now know the voltage of the battery is 30 volts. Again, the same circuit. This time we know the voltage of 100 volts that is pushing 2 amperes of current through an unknown resistance. What is the resistance in this circuit? Again, using Ohm's law, So that would be 100 volts divided by 2 amperes, or 50 ohms. So for a 100 volt battery would push 2 amperes of current through a 50 ohm resistor. Again, the same circuit, but this time we know the voltage and the resistance. What is the current flowing through this circuit? Ohm's law tells us that current I.
Okay, that is how to calculate using the formula. And next, I will show you one experiment, but a simple experiment. Just using power supply, ammeter, voltmeter, button, switch, resistor, 4 banana, lead, and okay, what that's happened is they are connect the wire from generator to voltmeter to measure the value of voltage. Okay, I will show you again next time. Okay, next, this is simulation, the simple simulation that you can use to get the value of current when you change the voltage and resistance. Okay, this is voltage and this is resistance. When we change the value of voltage and resistance, the current will be changed because V is directly proportional to the current. When voltage is 9 volt and ohm and resistance is 544, the current will be 16.5 milliamp. Okay, that is example of the simulation. Next, I will show you quiz, and let's do the quiz. Hello. For this question, you have to choose best answer to circuit completely, or bulb will bright when the circuit is completely connected. So, let's begin. Question 1. What value of voltage would cause 20 amp of current to flow through a 500 resistor? Got the answer? 0.04, 2.5, 25, or 10,000. Got the answer, guys? And girls, we try. Correct. Good. Next question. Second box. Ohm's law describes the mathematical relationship between ohm, kilo ohm, mega ohm, resistor size and value, resistor value, resistor voltage current, none and above. What? A. Let's try. Oh, try again. V equal to IR. When V equal to IR, so V is voltage, I is current, and R is resistance. So the answer is C. Alhamdulillah. Next question. If doubling the voltage and doubling current through resistor, then the resistor value does not change. Resistor value increase, decrease. Yeah, good. Not change. Try. Alhamdulillah. Next question. What the resistor value given circuit? 26 divided by 13. 2. Right. Good. What is the value of current given circuit? 14 divided by 20. The answer is 0.7. Good. And last question. What is the current in the given circuit? 7 volt and 5 amp. Oh, okay. Brilliant. Okay, congratulations. Thank you for your cooperation. Well done. The next chapter is series and parallel circuit. Thank you.